our next speaker from Software Mansion. Everyone give it up for Lukasz! Yes! Woo!
OK, I think we can start. So let's meet Dave. He's a software engineer working on mobile app using React Native. He's really good at it, but he doesn't have any experience with native mobile development. One day, Dave's boss sent him a list of new requirements for a mobile app. That list was impossible to fulfill for Dave, and it was quite ridiculous. But Dave needed to meet those requirements to satisfy his boss and not lose his job. So Dave did what everyone else would do in his position. He started searching for help. Recently, React Native ecosystem has been thriving with a wide array of modules available. You can easily find what you need. You can, such as Expo Video, React Native Video for video-related tasks, or even libraries to display charts or 3D graphics. But each project is unique, and sometimes the key is to do something different than everyone else. That is when you might find yourself looking at the blank result screen. Or maybe you need to use certain third-party libraries. So for sure, at some point, you will end up on that screen, just like Dave did. That is where most people start to panic, because they are not familiar with native tooling or different workflows that you have to learn. But really, is there anything to be afraid of? Today, I want to show you that you don't have to be afraid of writing native code. It's just a code, like everything else. And if you are familiar with programming, it won't be a challenge for you. You can build your first module even today. So, hi, I'm Lukasz. I'm working at Software Mansion on Expo. And I think we can start. So, what we can do first? I think the best advice is to just search for help on how to get started working on native module. You will quickly learn there are 3 parts that compose a native module. A static specification defined using a type system, like Flow or TypeScript. Generated glue between JS and the native world, and the module implementation. So the TypeScript spec or Flow spec makes sure that everyone else will use your API correctly. On that slide, you can see a pretty easy spec for a module that contains only one method, add. The CodeGen is a tool that takes the spec and creates a conversion layer between JavaScript and native using some C++ magic. Usually, it's added as a build step, but you can run that command on your own and play with the output and see what will be generated. And finally, we have the meat of our module, so the native implementation. On that slide, you can see implementation of the add function using Objective-C on iOS. That system is called TurboModules, and you will end up using Objective-C on iOS and Java or Kotlin on Android. That is cool, but it seems really complex, isn't it? Are you supposed to deal with C++ layer? What if the native API is different on each platform? Or you might be curious about those and many other questions about that thing. So for those who still think it is a little bit too complex, there is actually another way of building native module. You can use the Expo Modules API, which was built on top of the JSI, so you won't lose any performance. That is the same tech that powers the TurboModules. It was designed to be modern, so you can use Swift and Kotlin, and it will work very nicely with the newest feature of those 2 languages. There is no need for additional tooling, such as CodeGen, and we put a lot of effort optimizing the time that we need to spend finding our modules, so it won't slow down your process and build systems, even if you have a lot of them in your projects. And I've been thinking a lot how I can showcase you the Expo Modules API, and I decided to go with example. And normally, that is the part where I'm doing a live demo, but every time I do, something just blows up, so maybe it's not a good idea for today. We will be sticking to slides. And I prepared a simple demo. We'll be implementing the clipboard module on Android. OK, so we can start by defining a class. We can choose a name here. It doesn't really matter, but choosing something meaningful is always a good idea. However, it has to extend the module class. That class gives us access to some helpers, other modules, or functionality like sending events. So it's a nice base on which we can build on. We need to also override one function called definition. The definition is just entry point for our module. Here, we can describe how that module would look like, what parts will be exported to the JavaScript, using DSL-like syntax. And here we can see the first component, which we need to learn, the name. That name tells our API under which key the module is exported. Using that string later, we can basically get our module on the JS site. OK, now we can start to implement something useful. So we can use async function component to describe a function, to export an async function to the JS. That component takes two parameters, the name, which is just a string, and the body, which is just a lambda that also can take some arguments. But for now, we will leave that empty. So we just exported our first function. It doesn't do much. We need to now somehow access the native clipboard. That is quite simple. We can obtain the clipboard manager using Android context. But what is Android context? Context is just a big box with all the important stuff for your app. Basically, all the shiny tools are in that class, letting you use some services, hardware sensors, and more. So we can access it via another context, which is funny enough, the app context. The app context was provided by the Expo Modules API to give you modules-related stuff. And yeah, that's it. That's what we need to do to actually get the Android context. However, the context may not be available, and we have to handle that case somehow. While working on multiple Expo modules, we found out that we are following the similar patterns for reporting errors. Each package has its own string that is passed as a promise rejection if the context isn't available. The same problem is described using a different sentence across multiple packages, which make your users confused. So we decided to provide a set of common exceptions that you can reuse in each of your package. And here you can see one of them. And we are throwing. Does it mean the app will crash? What will happen? So if something throws inside of the async function, inside of the lambda we defined previously, it won't be a crash. It will be converted into promise rejection. So basically, you are using the native way of saying, OK, something went terribly. We need to handle that somehow. And we have to handle that on the JS side, but it won't crash your app. OK, we have the context. So now we can get the clipboard manager. Also, quite simple. We are defining another property. That is how you can get system service from the context. Normally, those kind of lines you will find in the documentation, so you don't have to understand them. You just need to Google. But there is one important part, that question mark here. It means that the clipboard manager may not be available, so we need to handle that as well. So let's throw something, but what we should throw. So as you may guess, we cannot provide you a default exceptions for everything. You have to sometimes create your own one. So we can do that really quickly. So to define exceptions, we just need to define a class that extends coded exception. By doing that, we are saying to the API that that exception was meant to be thrown and was meant to be sent to the JS site. If you throw something that doesn't extend the coded exceptions, it will mean it was probably unexpected error. It still will be a promise rejection at the end, and still you can handle that on the JS side. But we are distinguishing those two cases, and if you are not extending the coded exception, we will be wrapping the error with the unexpected exception at the end. Also, we can provide the message to clarify what happened to the users. OK, we have that. So now we can implement our function. OK, so I'm using the clipboard manager to get the primary clipboard and the first item. And then I just convert it to a string. Everything else will be handled by the API. You don't have to do anything else. That is cool, but the clipboard can contain different data types, such as plain text, HTML, or even images. We should handle at least 2 of them. For that slides, you can handle images on your own if you want. But we need to get a user input on what type is expected. So we will end up adding another first parameter to our Lambda. But let's define types first. So I would like to use enums to represent the difference between plain text and HTML. The name here doesn't really matter, but that string is very important. That tells the API by which type your class should be represented on the JS side. You can choose between strings and ints and other types here, but probably strings and ints are the most common one. To make it convertible between languages, we need to implement a special interface. And then you can just provide your values. The first part is the native identifier used in Kotlin. And that string is the string which will be converted into or from on the JS side. That would be enough, but when dealing with options like that, it's always a good idea to wrap it inside of some kind of object to make it possible to extend in the future without changing the API, because you can provide a default value, and that would work. So we can create a class options that extends record interface. Here we are facing another very important concept related to Expo Modules API, records. It is a struct which allows each field to have its own type, and you can also provide a default value. This makes it perfect to describe plain data classes, objects that are sent between JS to native or native to JS. So basically, we're saying that function will need an object with a property called format. The syntax here is quite simple. The property name will be used as a key. We need to add a notation to make sure that property will be part of the conversion mechanism. And you can also provide the default value. Now we can come back to our function and start to modify the body. OK, so I've added the additional argument. And now I can decide what to do with data based on the user input. OK, we created first async function, but we can easily switch it to synchronous using a different DSL component. It's not a big deal since we are not doing anything fancy inside of the Lambda. We are not switching threads. We are not running anything that may block the JS thread. So changing the function type is quite simple and let you test different ideas and see what would work best for your application. OK, we did it. We implemented our own first module. It wasn't that scary. And the Expo Modules API has a lot to offer, but I won't be able to get into details about every DSL component, about every functionality it provides. However, I want to mention a couple of features that I found quite interesting. So we support the type arrays known from JavaScript. You can use them as an argument for a function, or you can just return them. They are very useful when you are dealing with audio or video processing. They let you easily share huge chunks of raw memory between languages. They are also optimized by JavaScript engines, so probably is the fastest way of doing things like that. And currently, they are not supported in TurboModules. Our API also provides you ability to describe classes, which will be represented by the JavaScript prototypes. Each class can have its own methods, properties, and even events. That feature may seems quite simple, but actually it is really powerful because it allows you to create objects that exist between languages. Making it like with that, you can easily make object-oriented APIs. The object can also have a native state. And I have example for you. So here you can see a player defined in Expo video package. That player contains information about the current frame, current status of the video. It was created using a hook just to connect it with the React render pipeline. But you can use the plain constructor if you want. However, the data on the native side is quite heavy because we are basically holding a buffer there. So we want to ensure that we can release as much memory, as much resources as soon as possible. So we want to deallocate the native stuff when the component is unmounted. That's why we have that hook in our API. And everything else would work as you expected. So you can have getters, setters, and functions that will change the native state, will change how the player is behaving. And to use it, to display the video, you can pass the player object to the native view, and that's it. And all that API was defined using only DSL without any need of extra JavaScript code. So you don't have to switch between languages. You can define that fully on the native side. Now you can see a comparison between old and new API exported by the Expo image manipulator package. When creating that API, we focus on using classes as much as possible. I think the result is quite nice. We have a simple and ergonomic API. Also, after each step, you can display the preview of that image without saving it onto the disk, which is quite nice and quite fast. It's not available yet, but it will be soon, so stay tuned for that. And like classes and modules, you can also define native views. When using a traditional way of creating native view, you will often end up duplicating some part of your implementation for both for old and new architecture. And the biggest advantage when you are using Expo and Expo way of creating native views is that you can reuse the same definition. The same definition will work on both Pair and Fabric, so you don't have to change anything. You get that for free. So how can you start? Creating a new module is quite simple because we have a command for that, like always. So you can run npx create-expo-module to create a new, fresh project with everything set up to be released on the npm. However, you can also use the local flag, add the local flag, because probably you have an existing project and you just want to add some native functionality to it. That is the easiest way to actually do it in such a case. OK, so the Expo API isn't only used by the Expo team. Community members have made a bunch of awesome packages with it. Here you can see some of them. We're really happy that people start to using the API. Because of that, we were able to find, to spot and fix some bugs, and even introduce new features. So make sure to check out those packages. They are really awesome. Yeah, and that would be it for me. If you have any questions, feel free to reach out on the GitHub or on Twitter. And yeah, thank you for listening, and happy coding.